Pozdrav ekipa, evo danas nastavljamo onda dalje i evo ovdje vam isto šaljem još jedanput ovo što smo bili napravili prošli put, ali sada sam vam dodao i na engleskome na što trebate paziti i kako se stvari izgovaraju. Znači intervala na engleskome interval i to je set of real numbers lying between two numbers. We can have included situation between these numbers, we can exclude them also, and we have combinations. And the last thing that you have to watch out, that the interval itself, it's defined as all the numbers that are between A and B. So whenever we talk about it, the left number or the first number in the interval is always the lesser number. So watch out for that. So the last example, where we go from 3 to -2 and the numbers between them, this is not correct in mathematics. Okay, today I want to continue on, and I want to talk to you about intervals a little bit more. But in this case, if we have a situation, let me just make it right. Hopefully we can see everything. Okay, it should be done. Now, I want to talk to you about, again, intervals. We're still in them a little bit. And situation like example this. So example 1, what is an interval that is all the numbers, for example, x's, that are less than 3. So this is basically in equation at the moment. Hrvatski nejednadžba, znači da znamo i to, ali se nejednadžbama ćemo se još baviti malo kasnije. Sada se bavimo isključivo sa skupovima, odnosno s intervalima. So in this case, let's draw the number line. Let's start with that. Let's put the 0 and 1. Let's add the 3 because 3 is a number that we need in all of this. 1, 2, and 3. And these numbers that are less than 3 should be all numbers that are on the left side from number 3 on the number line. So one thing that we have to note, so in this here case, we have the less, strictly less. So the bracket that we're going to use is going to be the bracket that is excluding the 3. So all the numbers that are on the left side, so we can put the interval like this. Okay, so in this case, let's say we have an issue. And the issue is what is happening on the left side. Where is the beginning? Well, technically, beginning doesn't exist because you can pick any number in the minus specter, and it can be defined as the end. But it's not correct if you put an actual number. So in that case, we can go towards minus infinity, and minus infinity will be our left side of the interval. So basically what this means is that we have the interval where x is element from minus infinity to 3. Now look at how I've put the bracket, or which bracket did I put? Now, so you know, in mathematics, you're going to see in some of the textbooks that they use the bracket for including, but we generally say that we are excluding minus infinity because minus infinity as a number, it doesn't exist as itself. It's a term for something that is extremely to the minus side, something extreme. Okay, now this is just the idea, okay? This is not actual math. I'm not gonna go dwell with that too much. But if you put this bracket also, it makes sense. It doesn't matter, okay? But technically, you will always find me using the bracket for excluding the minus infinity. Okay, so because, let's point it out, here is minus infinity in all of this. Okay, let's continue on. Let's continue on with another example, example 2. And in this case, I'm going to have all the numbers that are greater or equal than 0. So x is greater or equal to 0. Okay, once again, we go with the number line, just so that we can position ourselves. I always advise you to use it. Please don't be afraid of it. Don't take any, I don't know, do all the steps. There is no need to skip them, okay? So in this case, okay, I'm gonna put 0, I'm gonna put 1. I still need to know how far is between the integers in this case. Well, the 0 is already pointed out here. I don't have to go extra with it. Now, in this case, we have greater or equal, which means we are including the 0. And all the numbers that are greater or equal to 0 should be on the number line to the right side. So we can say they are like this. And the 0, because we have 0, x, or the values or the numbers can be equal to 0. In this case, we are including the 0. Now, our interval has the beginning. That's a good thing, but we are missing the ending. Well, we are not actually missing it, because when we go towards right, or when the numbers are to the right, they are also going to plus infinity in this case. So we can say that this is going to be our endpoint, so to say, or end value. Now, how to write it down? Well, x is going to be element of 0 included to plus infinity, x included in this case. So watch out for the bracket just. We are including the 0, while you can pick, if you like, whichever bracket you want for the infinity. Same is for the plus and the minus infinity. Just we have in this case plus infinity. Okay, so these are two now new extra intervals that you should have done, I believe, in the primary school. If you haven't done, don't worry. This should fit easily. And well, basically what you can do, pick any of these situations with different numbers, use some positive, use some negative, you can use also decimal numbers, you can use pi if you like, and try for yourself the number line, and then put it into the interval form, so to say. Okay, so this is what I wanted to finish about the intervals from the last time. Last time we talked about it, we had an introduction to it all, so I didn't want to force everything. And today we're going to continue on with the new title that's considering the sets themselves. So we are not moving from that part of mathematics, we're still in that. Let me just put in the paper so it works. Okay, hopefully it was going to be fine. There we go. And now today's title is going to be first title. We're going to have two of them. The first title is going to be relations between sets. So for the examples today, I'm going to use basically just the just two sets. You can also apply it to 3, 4, I don't know how many you like, but we're going to concentrate on just two of them for now. We're not going to complicate things at the beginning. So there's a couple of relations that we can look between the sets, and I'm going to start with the simplest one. Two sets can be equal or they can be different from one another. Basically, if you have set A and B, so these are two sets, they can be also in a interval form, they can be in a set form, so depending on the bracket you're given or the task or the example, we're going to see it in a second. Well, it doesn't matter in that case. We can either have a situation where they are equal, so A is equal to B, or we have a situation where A is different than B. So these are the two basic situations that we can look between two sets. Now, let's look at the example 1 in this case, and A. So if you're given that A set is, for example, numbers 1, 2, 3, 4, and 5. So we have these 5 numbers. I'm going to stick to the simplest ideas. I'm not going to complicate stuff. This should be pretty easy at the moment. So this is a set. Why is it a set? We have the brackets that tell us that we have the set itself. Okay, so these type of brackets are for the sets. Oh, okay, so let's put the also what is going to be the B set. Let's say that we have still 1, 2, 3, 4, and 5. So this means that here we have the actual numbers 1, 2, 3, 4, and 5. So how do we check the relation between them? Well, basically, you can say, do we have all elements of these sets? So elements are numbers like 1, 2, 3, 4, 5 in both of them, and that we don't have anything extra. So in this case, well, 1 is in both of them, 2 is in both of them, 3 is in both of them, 4 is in both of them, and 5 is in both of them. We don't have anything extra. We don't have something that is only in one of them. So each of the elements of the A set is also in the B set. There is nothing extra. So we can write down that A set is equal to B. Simple as that. It's so far like in mathematics, normal. Or normal algebra. Okay, let's look at the example B now. Now I'm going to change things a little bit. I'm going to, in this case, add the C. And I'm going to write down that the C set is going to be 1, 2, 3, 4, 5, 6, and 7. Now, I would like to compare this set, C set, for example, to the A set. Now, you can already tell me, well, probably we don't, these A and C set are not equal. Well, why are they not equal? Well, you have two extra numbers or elements of the C set. These are values 6 and 7, or numbers 6 and 7, which are not in the A set. So we can write down because of that A is different than C. You can also change the order. You can say B equal to A and C not equal to A. It doesn't matter. The order you pick, it's okay. So this is as simple as that. Now, there is another relationship in all of this. There is a relationship between, actually there is a relationship between A and C. If you look at them, you can see that in both of them we have common numbers. So in A and the C set, you have 1, 2, 3, 4, and 5. You have in both of them. So this means that this here part is actually like A set. So this is basically A set in this. So how you can say it? Well, A is in the C set. We usually say it is contained. So A is contained in C. Okay, it is contained. It's inside of it, basically, when I put it bluntly. Okay, so this here is has also its specific symbol, or how do we write it down? So instead of saying it contained, we can write it down as A is subset of C. Okay, so this contained is used as this symbol. Now, I said something different here. I didn't say contained. I said the first time subset. Well, this is the second relation that we're going to look at. So one relationship is that they are either equal or not equal. If they're not equal, then we can compare them in a way if one of them is subset or superset of the other one. So A would be a subset because it's contained in C, and C would be superset because it contains whole A and then something extra. So we can also write that down. So we can now write down vocabulary for all of this. So A in this case, let's name it down, is a subset. C is superset. And the symbol here is A subset to B. A subset to C. Or contained. In. Now, I'm not going to usually say it's A is contained in C. I'm going to usually say that A is subset to C, but A is also defined as a subset itself in all of this. Now, there is something specific about this subset talk when we were talking about it. We can also say, like, if you look at it like this, it should remind you of something like this. Okay, so less or equal. Well, basically, A is less or equal to C in this case. But we can also say, why not put it that in this here case, A is definitely less than C. It's not equal. While in this here last example, where we have equality, where here I can apply this equal part. So this is something extra. Now, what does this mean? Sometimes in mathematics, you're going to see that that A and C relationship is going to be written down as A is proper subset, I'm going to talk about the proper, of C. So this is basically without the extra line. This here line is like in the less and equal, the equal part. The line itself is the equal part. If I don't write it down, it means that it's strictly less. In this here case, we can say it's strict subset of A is strict subset of C, but instead of that, we are going to say that A is a proper subset. Now, consider Croatian language. Znači, idemo se sad kratko prebaciti na hrvatski jezik. Znači, ovaj prvi dio bi vam trebao biti lagan u smislu toga da ovo je odnos između skupova brojeva. Mogu biti jednaki, mogu biti različiti. Znači, primjer A nam je bio kada su jednaki, primjer B kada su različiti. I kada su različiti, onda možemo pričati o priči da je, na primjer, subset je na hrvatskome podskup, superset je na hrvatskome nadskup. To si možete dodati i zapisati na hrvatskome, znači subset je podskup, a superset je nadskup. Pa da imate i tu verziju da znate na hrvatskome što se događa. I ovo je doslovno operator ili ti možemo možemo reći simbol za podskup ili nadskup. Znači A je podskup od C ili u ovoj tu drugoj situaciji A je pravi podskup od C. Vrlo jednostavno za sada. Nadam se da to možete shvatiti pa da nemate problema sa time. Znači, to je nekakav odnos brojeva koji možemo gledati. Now, let's go back to English. Now, look at the example. I'm going to give you another example. Example 2. Now, let's talk about, in this case, what is going to be given. So, let's say that A is a set like this. 1, 3, 5, 7, and so on. Well, probably what you should find out here that we're talking about the odd numbers. So A set is basically the set of odd numbers. For those of you that don't remember what are odd numbers, to su neparni brojevi. Tako da znamo i taj podatak. So this is the A set. Let's put the B set in all of this. And I'm going to say that B set is going to be specific numbers. I'm going to say it's 1, 11, 111, and so on. Well, what comes next? What do you think, guys? Well, now we were in a class, we will have a discussion about this, but since we're not, the next number should be 1111, and so on and so on. So in this case, we have also specific numbers in this set. I didn't put finite sets. I've put infinite because we can talk about infinite sets in all of this, and I think you are advanced enough so that we can talk about these infinite sets because they have infinite number of members. But there is a relationship between them. First thing is A equal to B? Of course it's not. Of course it's not because, well, there are a lot of numbers in A set that are not included in the B set that we don't have. While on the other case, all members or all numbers in the B set are included in the A set. So there is a relationship between them. And that is, in this case, that B is subset, for starters, of A. Because 1 is in A, 11 is in A, 111 is in A, and so on and so on and so on. So basically, if all members of one set are also members of the other set, while in this other set there are also some members that are not part of the starting set, so in this case B that I talked about. That means that A is superset of B, or B is subset of A. Now we could have written it down also, so this is up to you how you decide in this here case. We can say certainly that B is not equal to A. In this case, I can also move or write it down without the line, or without equality itself. Without equality, yeah, that would be the better term. And we can also write that B is proper subset of A. Okay? So this is just the example for you so that we can talk about it. So these are the relations between these two sets. And when you look at it like that, you can see, you can look at a lot of examples in your textbook. I'm going to give you the directions on, or what to do in your textbook afterwards. I'm not going to talk about it here. I want to concentrate on all of this, so you can try it out for yourself. But before I continue on, there is one thing that I want to talk to you about that we know so far. So we know specific general types of numbers that we ordered in types of sets. So what I'm talking about here, we know about natural numbers, we know about integer numbers, we know about rational numbers and real numbers, and they're all specific to one another. And we should know their properties, and we should know their relation with one another. In this case, what I want to show you is that you can use more than two sets to compare them and see what is going on between them. So I'm going to start here with the one that is the subset of them all, and that is the natural number set. All natural numbers are contained also in the integer numbers, in rational numbers, and in the real numbers, because natural numbers are positive, positive integers. They also can be written down as fractions, and real numbers are all real numbers that we use in mathematics, including the natural numbers. So I'm going to start with the natural set. I'm going to start with it. Now, the next set in the line, or the first superset to natural set, is the integer numbers. Because all integer numbers have positive integers, have 0, which is something extra, which we don't have in the natural, and we have all the negative numbers. Negative, yeah, so to say. So we can write down, in this case, that N is proper subset of Z set, or, so to say, integer set. Next in line, well, you should know that it should be Q already. So Z is a proper subset of Q, because all integers are part of the rational numbers, because you can rewrite any integer as a fraction, while there are some numbers like 1/2 or 3/5 and so on, that which are fractions, which we cannot write down as an integer. Okay, and the one that is above them all, or so to say, the superset daddy of them all, is the real set. And this is the relationship between the sets that we know. Now, there is one set that I didn't include in all of this, and that is the irrational numbers, like number pi, like number e, and so on. And, for example, the square roots and, square root of 2, square root of 3, and so on. So, where does it come from? Or where does it land in all of this? Well, what you can say here is that, so we have irrational numbers in a special case. Well, irrational numbers, they're not integer, or none of the integers is also irrational. Also the integers and natural, both of them. Also, irrational numbers are defined as the numbers that you cannot write down as a fraction, so they're also not Q. In all of this case, what I can write down for the relation between n, z, and q with I is that they're not equal. But I also cannot write down that n is subset of I, or z is subset to I, or q is subset to I, or opposite, that I is a subset of q or z and n. Okay, so these are definitely separated. They have nothing in common. They have nothing in common. While the last two guys in all of this, or last two sets that we can compare, are real and irrational. In this case, real set also contains the irrationals. So it contains all rational numbers and all irrational numbers. So relationship in this case, we can be written down as I is subset, proper subset, again, of the real set. Hope I helped you out with this. So this is the relationships between them. This is a little something for today. I'm not going to bother you anymore. I'm going to give you homework on Lumen or on in our group. So watch out for that. I don't want to give you any more examples for today. Thank you very much for listening and hope you learned something. If there is any questions considering any of this, you know where to find me.